In this section, we cover the test command. Now, in elaborating further on the bash basics, test is a command that allows bash to perform conditional testing on strings as well as files as well as integers. We're going to begin with integers because integers are typically easiest to comprehend. We'll then test strings. Then we'll show you the plethora of file testing capabilities that the test command allows bash. Let's open a shell. Now, the test command happens to be a command, a binary on your system, but bash can invoke the test command, and you can do a which test. As you can see, it's in user bin test. You don't need to memorize all of the tests that bash can perform, but bash invokes test whenever it needs to compare or perform comparisons, either on integers, strings, files, etc. And again, whenever testing within your scripts, you typically invoke the left bracket to instruct bash to perform a test. And you see them throughout scripts on your system, especially scripts that are shipped with the system. So let's perform a simple test, for example. We'll test integers. Let's clear screen. Now, here's something basic about bash. After running every command, similar to other operating systems, an exit status is returned. So by simply typing clear, for example, to clear the screen, an exit status is stored in a variable called question mark. This particular variable, if echoed, will tell you the exit status of the previously executed command, good or bad. In Unix terminology, 0 means good, 1 or some other code typically means bad, whereas in Boolean terminology, 0 is false, 1 is true. So you need to keep that in mind when programming your shell scripts, that the exit status's logic or exit status's return values are the opposite of the typical Boolean that other scripting languages and programming languages honor. So let's echo that exit status, and as you can see, it's 0, and even after issuing the echo command, it is 0. So let's clear screen, and the reason why we showed you the exit status variable, the question mark, the result, is because when performing tests, it's important to evaluate the value, the then current value of the exit status variable, so that you can make the appropriate decision. So we'll test, and when you want to test integers within a bash environment or within the bash environment, you use string-like comparisons, such as test1 equals 1. Unlike other languages such as Perl, for example, where you'd simply say test1 equal double equal 1, because usually a single equal is for an assignment in other languages. And you'll see as we test. But to test strings, we'll do test1, or to test integers first, we'll test 1 equal 1. And when we're finished, we'll echo the exit status. Now, simply cursoring through the commands in our bash history will not change the exit status. As long as we don't execute another command within our shell, we're fine. If we echo, 1 is equal to 1, and as a result, the return value is 0. So that's great. Whenever the return value is 0 again within the shell, then it is good. That is the Boolean equivalent of 1, or true. In other words, it's true, it's good, the command has successfully run. 1 is equal to 1. How about if we make this wrong by testing a different set of integers, such as test 100 is equal to 200. And once complete, we'll echo the same exit status variable, and this time, instead of returning 0 for a Unix exit status of successful or true, it returns 1. So again, we can test integers using the string-like comparisons such as dash equal, and there are others, of course, such as less than. Let's do a less than. Let's test whether or not 100 is less than 200. Now we know this is true, so this should return a value of 0. Let's echo the exit status, and it is 0. Now, to speed up the echoing of our results from the test command or from any command within the bash shell environment, we can employ command chaining. Now, we dedicate an entire video just to command chaining, but we'll give you a quick preview. Instead of actually typing test 100 or separate commands on separate lines, we can chain commands. So we can test whether or not 100 is less than 200, and then separate the subsequent command by a semicolon. So if there's a semicolon between the commands, then bash interprets the commands as separate, distinct commands. So test 100 less than 200, and then echo, once complete, the exit status. And there's the exit status, it's 0. So now with that in mind, let's keep the second command the same and keep altering our comparison tests. Let's test whether or not 100 is greater than 200. This should return 1. And I think you're getting the picture. So 100 certainly is not greater than. We can also test whether or not 100 is not equal to 200, and this will return a 0 value. We can also test whether it's less than or equal to, and it returns a positive value or a true value because it is less than or equal to. It's actually less than. We can test whether it's greater than or equal to, and it certainly isn't. We can reverse the numbers. Let's make this, for example, 500, the left side of the comparison 500, and we'll leave the right as 200, and this returns a true value because 500 is greater than or equal to. We can test other conditions such as not equal to, and it certainly is not equal to. So for testing integers, or for comparing integers, you have a few operators that you can use, or several operators that you can use that you'll find in most scripting and programming environments. You can test whether or not they're equal to. The comparisons are equal to each other. You can test whether or not one side's less than or equal to, greater than or equal to, not equal to. So we're testing for equal to, less than or equal to, greater than or equal to, not equal to, less than, or greater than. These are the typical ways you can test. You normally have these 6 different ways of testing at least integers. Now with strings it's a different story, although each character, because if you think about a string, a word for example, a word is none other than a series or a list of characters. So the name Dean, for example, is a list of the characters D-E-A-N, or the user account root is a list of characters R-O-O-T. There are ways to perform comparison tests on strings, but if you're testing less than, greater than, etc., you'll typically test the ASCII translation of each of the characters, whereas typically with strings you just want to test whether or not they're equal to each other. So let's test some strings. Let's test whether or not hello underscore world is equal to hello underscore world, and when it's complete we'll echo the exit status. Now notice that the equal sign is slightly different than what you may be accustomed to. In the Bash scripting environment there is a big difference. In other programming languages including Perl, Python, etc., including PHP, a single equal sign means to assign the left to the right. So typically when assigning values to variables, to placeholders, you use a single equal sign, and when performing comparisons you use 2 equal signs, or in the case of PHP you can even test with 3 equal signs. In Bash it's a single equal sign, so keep that in mind. Let's test and echo the results. The results are positive. Now let's alter these 2 strings. Let's make the left hello worlds, and the right will remain the same, and they're not equal. So the test command is able to deliver for Bash the test or the comparisons of strings as well as integers. We can test whether they're equal to. Now so far we've been just testing equal to on the 2 strings. How about if they're not equal to? We can negate our tests by prefixing them with the exclamation mark. This should come as no surprise because this is commonly how in most environments you test or negate a test. So let's test whether or not these are not equal, and this will return true, or a bash 0, a Unix shell 0, because the test is actually true. They're not equal to each other. How about testing whether or not 2 values that are the same are not equal to each other? That's certainly another option that we should consider. So for example, let's take 2 values like we originally had, hello world and hello world. Let's test whether or not they're not equal to each other, and this returns false because they are equal to each other. So we can test strings. Now what about files? Usually we test whether or not files are have certain properties. And there are all sorts of file tests that we can perform. We're going to perform a few of them, and we'll show you how to find the rest of them, because you don't need to memorize all of the tests. The ones that we've just labored through you should memorize, because most languages make use of the syntax we've just shown you. So in other words, greater than, not equal to, less than or equal to, greater than equal to, not equal to, less than, greater than, etc. The 6 that we've mentioned you should memorize. As well as for string comparisons, you should memorize equal to and not equal to, the negation of the two, because you often do that. Integers, there's no excuse, you should know them, because oftentimes you make decisions based on the values of integers, not necessarily based on strings. And quite often in shell scripting, you make decisions based on certain properties of files on the file system, since Linux, Unix is nothing other than one big file system with a plethora of files that we can test. Well, let's perform some basic tests. We need to create files to test. So let's navigate into temp2. This is typically where we've been working. This is where we have our shell scripts, other scripts on the system. So what we want to do is actually test whether or not some of the files on the system are newer than, older than, etc. You name it. Let's create 2 files. To create a file within a bash environment or within a Linux environment, use the touch command. Most Unix environments have the touch command. This will allow you to either update the access time and modification time of files if they do exist on the system, or if the file does not exist, it'll create the file for you. So let's create 2 files. We'll call the first one testing1 and the second file testing2. Now we'll create them separately at different times purposely. So if we LSL testing1, it exists on the system. Now let's touch testing2. Excellent. So now we have 2 testing files on the system that we can list, and we can use the test command to test against. That's LSL testing, and we'll just use the question mark. Here we have testing1 and testing2. Both appear to have been created at 1805, and they were, but seconds apart. So let's use bash to make a decision. We'll test, and we're going to test whether or not file 1, which we'll say is testing1 because we created it first, is newer than file 2, which in this case is testing2. Now let's echo the exit status, and it returns 1. So what this means is testing1 is not newer than testing2. Let's reverse the test. Test whether or not testing2 is newer than testing1, then echo the exit status, and the exit status is true. Testing2 is a newer file because we created it after, albeit seconds after, but it is certainly a newer file. So we can test whether it's newer than, we can test whether it's older than. In our first test, just change the newer than to older than, echo the exit status, and you'll see testing1 is older than testing2. There are other types of files on the system that we can test for. For example, on a Linux system, especially Red Hat, in order to get to your modem, for example, you typically address with your program such as Kermit /dev/CUA0, for example, for COM1, or CUA1 for COM2. These types of files are special types of files. They're not block devices. They're not normal files. They're character devices. We can test whether or not the file that we're interacting with from our script is a character or a block device, quite simply. Let's test using -b whether or not testing1, the file we just created, is a block device. Let's echo it. It echoes 1. Now let's test whether or not the file /dev, we'll test /c dev CUA 0 for COM1, and then we'll echo the exit return, and it is a character device. So for example, serial ports are character devices, and this test tells us that it is. So for example, just envision, try to use your imagination a little bit. If within a script you're interacting with a file and you want to be sure that it's not a character device, or let's say for example your script will write to a serial port, then you have a way through bash using test to tell whether or not you are indeed dealing with a character device. Excellent. So we can use C, we can use B for block devices. We can test whether or not a file actually exists. Now we haven't created a file called testing3. If we LSL testing question, there's no such file called testing3. Let's do a test to see whether or not the file exists. We use E to see whether or not it exists. Testing3. Let's echo the exit status, and it comes back as 1 because it does not exist. Now when you use E, it checks for both files and directories. Let's make a directory called testing3, and then let's rerun the test, followed by an echo of the exit status. The test succeeds with the -E option, whether it's a file or a directory, so that's something to be aware of. Let's remove RF, testing3. So if you just want to test whether or not the file is a regular file, use -F. Now what we're going to do is make that directory again, testing3, and just rerun the test we just showed you. This time we'll use -F, and we'll test testing3, and we'll echo the exit status. Now it's not a regular file. It happens to be a directory. We can negate the test and have it test to tell us whether or not it's not a regular file. So let's remove RF testing3 again. Now let's touch testing3, which happens to be a regular file, and use test-F again, and this time it is a regular file. So in your scripts, you want to test using the right test. Now in your script you're not going to actually say test. We'll show you later on. You'll simply invoke the left bracket followed by the test, let's say for example -F, and then the name of the file, for example testing3, and then you close with the right bracket, and then that'll perform the test for you. And if true, then the rest of the condition will be executed. You can test also if a file is a socket. There are tons of sockets on the system. If we LSL, for example, I'll give you an example of a socket that's on this system. varlib MySQL. MySQL is certainly running. The MySQL.sock file is a socket. It has a prefix of S. If you've used our earlier or other products such as Red Hat Edition, Debian Edition, etc., you'll know all about file systems, and you'll know that the first column contains the definition of the file. Well, when many daemons start, they create a socket. Well, let's test whether or not Bash can tell that this is a socket. We'll just test with the -S option, capital S that is, not lowercase s. Lowercase s will test whether or not the file's non-zero. We'll test -S varlib MySQL, MySQL.sock, and then we'll echo the exit status, and it is a socket. How about zero files or non-zero files? Well, let's test lowercase s testing1, which is a file we created earlier, and echo it, and as you can see it's failed because the file is 0. It's a 0-byte file. We can test some other file on the system. Let's test one of the scripts that we have created. We'll test -S, for example. Let's go with log1.log, and we'll echo the exit status, and as you can see it's fine. So there are all sorts of tests. Now to sum up what we've just gone through, simply do a man test and you'll see all the different ways that you can test. We just want to warm you up to it. Here's some ways you can test strings, or integers first and then strings using normal comparisons, normal operators, and the different file tests. And again, within your scripts you're going to prefix these tests with an open bracket and close bracket, and often prefixed by a condition such as if. In other words, if will perform if it's true or false. So you need to know about tests. We've told you about tests. We'll be using them. You use them in all programming languages to make decisions for you.